Okay, we'll look at another typical exam question on organic chemistry. Study the structural formula below, and for this compound, write down. So before we even look at the questions, we are given an ester. You can see the functional group there. That is an ester. Okay, and the name of this ester, remember this is the part that's coming from alcohol. So therefore, that will be ethyl because it has two carbons. That's ethyl. And then this is the part that's coming from carboxylic acid. So that will be what? Butanoate. Butanoate. That's coming from butanoic acid. This is coming from ethanol. This is from butanoic acid. Okay, so let's look at the questions. Write down the homologous series to which it belongs. And you know that this is coming from ester. So this is an ester. And IUPAC name, I'll just write it here, 10.1.2. IUPAC name, we have already indicated that this is an ethyl ethanoate. Okay. Next question. IUPAC name of the organic acid used in its preparation. And we've already said that this is coming from this part. That is coming from butanoic acid. So that will be 10.1.3. So that is coming from butanoic acid. Next question. The structural formula of its straight chain functional isomer. And functional isomers, we know that there are two pairs. We have a carboxylic acid and ester. We also have a ketone and aldehyde. So this is an ester. So its functional isomer will be a carboxylic acid. So which carboxylic acid is it going to be? We're going to check how many carbons. 1, 2, 3, 4, 5, 6. Right. So the carboxylic acid there, if you have 6 carbons, that will be hexanoic acid. Right. So that will be the structural formula of hexanoic acid. Remember, this is question 10.1.4. 10.1.4. So we know that functional group for carboxylic acid is C double bond O. The same C is connected to O and H. So therefore, we have 6 carbons. 1, 2, 3, 4, 5, 6. Okay, so this one we have double bond O and connected to OH. And then you just fill in the remaining bonds with hydrogens. Okay, then we are done. Then the next question, write down the structural formula of 4-methyl pentan 2-on. Okay, pentan 2-on, that is a ketone. So we'll have the functional group in carbon number 2. So this is a ketone with 5 carbons. So question 10.2, we are looking for the structure of 4-methyl and then pentan 2-on. Okay, so it's 5 carbons. 1, 2, 3, 4, 5. And then carbon number 2, we're going to put the functional group of ketone, which will be C double bond O, and that C must be connected to 2 other carbons. Okay, so that's the functional group. So we'll put the double bond in carbon number 2, and that C is connected to this carbon and that carbon. Okay, then carbon number 4 will have the methyl, right? So we'll have the methyl. So that is 1, 2, 3, 4. So this is where we have our methyl, CH3. So that's the methyl. And keep in mind that a functional group will always take preference over the branches. So functional group will always get a lower number, that's in carbon number 2, compared to the branch, the methyl. Okay, then we're just going to fill in the hydrogens, and then we are done. Okay, so that is 4-methyl pentan 2-on. Then the next question, consider the structural formula alongside. And then for this compound, write down the general formula of the homologous series to which it belongs. And we can see the triple bond there, that this thing is coming from alkynes. So what is the general formula for alkyne? That would be CnH2n-2. Okay, and then in the next question, which is the last one, they want us to give the IUPAC name. So with the IUPAC name, we need to work out the longest chain. So if we go like that, then we'll have 1, 2, 3, 4, 5, 6, 7, which that 7 includes our functional group. If we go like that, then we'll have 1, 2, 3, 4, 5, 6. That's not the longest chain. If we do this, 1, 2, 3, 4, 5, 6, 7. Okay, so this, and it's either that or this one will be our longest chain. So therefore, let's highlight our longest chain. So that will be our longest chain. And then we're going to number that in such a way that the functional group, the carbon with the functional group, will get a lower number. So if I go from right to left, 1, 2, 3, carbon number 3 is the functional group. From left to right, 1, 2, 3, 4. So that will be carbon number 4 with the functional group. So to get a lower number, we'll number from right to left. So it's 1, 2, 3, 4, 5, 6, 7. Okay. And then now we're going to look at the branches, which is there is 1 in carbon number 4 and carbon number 2. And then there is an ethyl branch in carbon number 5. There is a methyl branch in carbon number 6. Okay, so we have 2 methyls and we have 1 ethyl. Okay, so how are we going to name this? Ethyl comes before methyl, alphabetical, E before M. So it's going to be what? 5 ethyl. Okay, and then we have carbon number 2 and carbon number 6. Remember, the numbers are separated by a comma. And then we put another dash, because a dash will separate a number and a letter. Okay, so the other branches will be said is what? Is 2, 6, Then we have 2 methyls. So we write dimethyl. Then the longest chain is how many carbons? 7 carbons. So 7 carbons will be what? Will be helped. But the functional group is in carbon number 3. So it's going to be carbon number 3. And then the suffix for alkynes is -ine. So it's 5-ethyl 2,6-dimethyl helped 3-ine. Okay, so that's the end of that question.